Hi everyone. Today we are going to start talking about variables that have, or not variables, equations that have two variables in them. So we're talking about linear equations, and so they're going to use an x and a y. And we have the definition up here that a linear equation is an equation that can be written in the form ax plus by equals c. And that's going to be important there. Ax plus by equals c. And that is what we call the standard form of a linear equation. Now, there's also some other important parts of this definition. When we have it in this form, the a value, which would be the coefficient of x, has to be greater than or equal to 0. The a and the b, so the coefficients of x and y, can't both be 0. And a, b, and c are integers with a greatest common factor of 1. So there's a lot to consider there, but right now let's just focus on getting it into that form. So here we have an example. Determine whether y equals 6 minus 3x is a linear equation. And if it is, write the equation in standard form. Okay, well, let's see if we can put it in standard form. And I gave you a helpful hint here. You should always transform the equation so that the variable terms are on the same side. It's best to transform it so that the x term is positive. Your life will just be easier. So if we have, let's write the original, y equals 6 minus 3x. So again, I want my x term to be positive, so I'm going to add 3x to both sides. And now I have 3x plus y equals 6. And we say, does that match our description here? A would be 3. That's my coefficient of x. That's 3. B would be 1, my coefficient of y. And C would be 6. Okay, so A is greater than or equal to 0. Yep. A and B are not both 0. True. A, B, and C are integers. Yes. And they only have a greatest common factor of 1. Also true. So yes, this is a linear equation. Okay, and this is what it would look like in standard form. Now in example 2 over here, we have x's and y's, true, but in this term right here, I have x and y together in the same term. That is not going to allow me to transform it into standard form. So this would be no, not in standard form. Okay? The other thing that would make it not standard form is if you have an exponent other than 1. So if you have, x squared or y cubed or something like that, that's not going to be linear. All right, so go ahead and try these 3, determine if they're linear or not, write yes or no. If it is yes, write the equation in standard form. Okay, so in number 1, we'll check it. This is no, and again, that's because of that x, y in the same term. In number 2, this is yes, because we can simply add 4 to both sides, and we can say that 3x equals 16. This is what would be standard form, but remember, it could also be written like this, 3x plus 0y equals 16, and that matches that format a little better, but notice that that's equivalent to this. Okay, so this one is a yes. And number 3, this is a no, again, because of that exponent there. All right, now, moving on, we're going to talk about intercepts of linear equations. And I want to talk, here we have 3 lines. This is not on your notes, but I just wanted to point something out to you. If we look at the red line right there, my x-intercept, remember, which is where it crosses the x-axis, so it's this point right here, would be negative 3, 0. My y-intercept of that red line would be 0, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 0, 8, if I counted correctly. Okay, now my blue line, my x-intercept is at 2, 0. And my y-intercept is at 0, 1, 2, 3, 4, 5, 0, 5. And for my green line, My x-intercept is at 9, 0, and my y-intercept is at 0, 1, 2, 3, 4, 5, 6, negative 6. Now what I want you to notice here is that x-intercepts, so any point that's sitting on the x-axis here, will always have a y value of 0. And any y-intercept, which is a point sitting on the y-axis, will always have an x value of 0. And that's really important to understand, so that when we go to our next page and we need to graph a linear equation, we can use the intercepts to graph it. Okay? So here's the big main idea here. If we want to find the intercepts, we need to let y equal 0 and solve the equation for x. Then we're going to let x equal 0 and solve the equation for y to get our y-intercept. So let me demonstrate that for you right here. If we have 3x plus 2y equals 6, first I'm going to let y equal 0. Okay, well that becomes 0 and goes away. So I have 3x equals 6, divide by 3, and I get x equals 2. So one of my intercepts is going to be 2, 0. That's going to be my x-intercept right there. Okay. Then I'm going to start and write the equation again, but this time I'm going to let x equal 0 because of what we just talked about on the previous screen. So now that goes away, and I have 2y equals 6, divide by 2, and we get y equals 3. So that ordered pair would be 0, 3, and that's my y-intercept. And once you have those 2 points plotted, then you can just connect them with a nice straight line and put arrows on both ends. And that's how you can graph a linear equation. The other way that you can graph a linear equation is to make a table. So if you have an equation, the first thing you want to do is solve the equation for y. Okay? If you learned about this last year, you might have learned about it as putting it in slope-intercept form, which we will discuss in another lesson. But you want to solve it or transform it for y. So here's what they did. They added 2x to both sides, and that allowed them to have y equals 2x plus 1. And then you're going to select 5 values for the domain and make a table. Remember, your domain is your x values right there. You can pick any 5 values that you want, okay? But pick easy ones just to save yourself some hassle. So, like they did, -2, -1, 0, 1, 2, those are all good. We wouldn't want to pick 25 because I'm not giving you a graph that's going to show 25 on it. You wouldn't want to pick 3/4 if you don't have to because the grids are done by ones, and so you wouldn't want to have a fractional value if you can avoid it. Okay? So then once you make your table, you've got your ordered pairs, and then you can just plot them like that. Okay? So try these on your own, and then you can come back here and check. And number 4, your x-intercept should be at -1, 0. Your y-intercept should be at 0, -2. And then I cannot connect a line real well on here, but hopefully yours looks better. But connect your dots like that. Number 5, your x-intercept is at -1, 0. Your y-intercept is at 0, 1/2. And again, hopefully you can draw a nice straight line with arrows on both ends. Then in number 6, remember we want to transform it so that we're solving for y. So I'm going to subtract x on both sides. Then I can divide everything by -1, and I get y equals x plus 1. Okay. Then I can make a table. Pick any numbers you want. So if I put -2 in, I'll get -1. -1 gives me 0. 0 gives me 1. 1 gives me 2. And 2 gives me 3. And then you can plot those points and make sure you have it graphed correctly. But it should look something like this, give or take. Make sure your line is straight. And that's it. We'll practice that in class later. Have a good night.